Okay, I want to look at a problem from a video that I looked at on YouTube, and I kind of like the problem. It was sort of fun. I just thought about a different way of doing it. So, anyways, here's the problem: is this one with Alice and Bob, and they can complete a job in 2 hours, and Alice and Charlie can complete the same job in 3 hours, and Bob and Charlie can complete it in 4 hours. How long will it take the three of them working together to do one job? Well, you have to assume that each person works at a constant rate, whether working alone or with working with others. So the assumption is pretty crazy. The idea of somebody working at a constant rate is a little bit unreal, and the idea that when people work together, it doesn't change the way they work. So the assumption's a little bit crazy, but it's a fun problem. I think it's kind of interesting. Now, the way that the person in the video did it that I looked at, it's actually pretty good, and it's kind of thoughtful. This is how they did it. They figured out that, well, there's a percentage of the job Alice does in 2 hours and a percentage that Bob does in 2 hours. And that percentage is like A. Let's call that percentage A. And it adds up to one job, 100% there. And the percent that Bob dubbed is B. Well, if they do it in 2 hours, you can get a formula. 2A plus 2B equals 1. And you do the same thing, and you factor out the two. 3 hours for Alice and Charlie, 4 hours from Bob and Charlie. Then the problem is what you're trying to do is when they work together, how long will it take? Well, they set this thing up here like this linear equation. Then they multiplied by factors so they'd get exactly the same number of 12 here, so that they'd have a common factor of 12. So they multiply this by 6, everything here by 4, everything here by 3, and then they just add it all up and they get 13. They get two 12A's, two 12B's. That's 24, and they factor it out, and woo, they're looking at the answer. 24 over 13 hours is the answer it'll take them to do it together. Well, that's pretty good, but I just thought of a different way of doing it. Why not think about it in terms of the percentage of the job done? Just think, well, Alice and Bob work at a rate of one job per 2 hours. Alice and Charlie, one job per 3 hours. Bob and Charlie, one job per 4 hours. And then just add it up. You get 2A, 2B, 2C. You add these fractions, you get 13 over 12. Factor out the 2, divide by 2, and you're looking at your answer. They do together 13 jobs in 24 hours. So we just invert that to get the hours per job. 24 over 13 hours per job. So whatever that is, an hour and 51 minutes, I think it works out to about. But there's your answer. For me, that feels a little bit easier. I don't know. I just thought to look at another way to do that problem would be sort of useful. So I did.